All right, we're back with more DSPy. This time we're going to continue the series where we left off last time. Where did we leave off last time? Let's see. Maybe it's a good time to actually switch to the coding scene a bit. And interestingly, this is what happens in larger projects. I don't really remember. I know what I want to do for today. Well, okay, let's switch back to this. So today we know what we want to do. What I want to do today is set up, or we should do a bit of research on data samples. Okay, remember, it's competitive coding problems. So we're gonna look on Hugging Face, maybe other data sets. There's got to be a data set though, because this is pretty common, you would think so, right? Everybody in AI for coding these days wants to solve LeetCode problems. Other than that, in core infrastructure, I think from last time we had this item, monkey patch. Yes, we need to finish this. We need to monkey patch the project manager we wrote last time into stream.feedback, which sounds like a mouthful. So let's remember, what the heck did we do last time? Let's see. Before this, now let's see if I can retrieve the diagram we had. Yes, we can. Okay, very good. So this is kind of where we left off. So let's see. So we have a problem description and input-output pairs. This is going to be the data set part. Okay, so this is what we'll do today. So we can call this send backwards, send to back. So this is called data set. And it can be, it's training test, right? We don't know what those are yet. We'll figure out what that is. It has nothing to do with the programming language, right? This is just an abstract problem description. Actually, it's probably worth putting out that this is, well, no, it's clear it's in natural language, right? And input-output pairs, numerical values of some format. That's why we're kind of prepared for this though, because we worked with jagged arrays last time. And okay, so we have this data, and the central module is this competitive coding problem solver. Now, if we look at the code, it's this module here in DSPy, which takes 3 inputs and has 5 outputs. The 3 inputs are the problem, the test cases, and the special input, which probably should be last, which is sort of the file structure we want for the solution code. And this is called the project. This is like a fake input. This is not a natural language input. It's more of an, we can view it as a DSPy infrastructure input. The 5 outputs are, there's 1 natural language explanation, which we don't really do anything with, to be honest. It's just nice to have. This could be consumed by a judge or something downstream, TBD. And there are 4 code outputs. There's the solution in a language, whatever we want it to be. Now, I was thinking today I kind of wanted to do some cross-language stuff, but I remembered I'm on Windows and it's not that easy because you have to install different tool chains. So we'll leave that for another time. Maybe we'll solve, ideally some other time, what we'd like to do is we'd like to solve the same problem in like 5 programming languages. But also I realize we don't have problems to solve, which I'll get to, we'll recap in a bit. So there's the solution code, the runtime and memory profiling code, and the test code that actually uses these test cases. Okay, nice and good. And we did a bunch of stuff with prompting, and specifically all this most of the work we did so far in this series is related to this special project input, which kind of informs us how the solution should be written on disk. Now, let's see if we try to run this. So if I remember correctly, we're gonna have to delete these files, output and output meta. And right now we're hard-coded in Python. I remember now what that task was, to shim in the files. So we sort of wrote two different types of AI. This is the, well, let's go back to the diagram. So it's all nice and good. This is our main problem-solving AI. So this is kind of nice and good, except it'll just output the solution code and memory and correctness and test code. The thing is, what if we want to actually run this code? And the explanation. The explanation, we're not really going to do much with it. Oh, I see. We have the color-coded inputs here. So this is natural language. These are code. Now, here's the trickery, though. How do we know that the solution actually works? And how do we know that the test actually exercises the solution and actually runs and actually passes? So that's what I would call second order. I would call it second order AI or something else. Maybe that's not the best term, but the point is we're gonna have to take these outputs, all four of them, or maybe just the test one, but we also want, now you can notice here that these are nested. That's because we also want the test code to actually use the solution and memory and runtime measurement code. That's already not easy, because if we just ask AI for test code, we used to call this in the beginning of the series leaky logic. What if the AI decides to redefine the solution inside the test code, maybe in a way that such that it always passes? So that would be like reward hacking, and we don't want that to happen, right? We want the test code to be clean and also exercise the solution code. And here we ran into a big snag for two reasons. This implies working with the file system. So we need a project structure. We need these codes, four of them, to live in, let's say, 4 files. Or maybe a single file, but they're all concatenated. Regardless, we need some sort of file logic, okay? So that's dictated by the project structure, which tells, and what that does, now what do we do with it? Okay, if we have this code, we can organize it in the project structure. But how do we make sure the AI actually uses the solution in the test code? Well, the only way we know how to do it, and it's generally possible, principled, or the intended way to do it is through prompting. So we're just gonna have to tell the AI, hey, when you output the test code, make sure you reuse the solution code. So that's what a DSPy adapter does, is it reads in, this is the adapter we wrote, okay, in one of the previous episodes. It reads in the project structure, which is a file, it's a custom, a very bare bone file structure we wrote in Python. And it turns it into prompts for the AI that tell it, hey, the solution will be, or the test code should use the following statement. Now, the thing is, the concept of reusing code is language dependent, okay? And hence we introduce the terrible dependency on, let me redo this, on the programming language. And this is kind of where we wanted to go, get to, generally speaking. Why are these arrows so whack? I don't like these. Okay, I don't like this either. Okay. How about we do it like this? Okay, so the concept of reusing code is not that easy to do in general, or some human would have to write it by hand. In Python, we know we have import statements. Okay, so from file import function, for example. So then in Python, the file adapter should write the prompt to the AI. If the programming language is Python, two things should happen. The file adapter should specify those prompts, and also the actual writing of the files to disk should be done in a certain way, because Python also needs, for example, __init__.py files in folders to properly import. This second part we did last time. So that's a project manager that writes Python code that organizes code in a certain programming language. This other part we didn't write yet. There's still a catch here. But what I'd like to focus on today is the dataset part, because if we go now, again, the goal is to just solve competitive coding problems, but in any programming language and with files on disk, okay? Not just because, okay, if you give the user, let's say you want to deliver this to a paying customer or something, you're gonna have to give them an AI module, or you're gonna have to give them not an AI module, but complete software that actually writes the solution to disk and exercises it, which is kind of the whole point of this thing. Now, the other limitation is so far we've only in the main code. So today let's run again the main code. Let me remember what this was. So first of all, first and foremost, I think we need to do one thingy here. Oh no, we're on DSPy. Oh, okay, so we are on DSPy nightly. We should not be on DSPy nightly. Okay, we should be on DSPy 310. Let's do a UV sync. Because ever since we talked last time, okay. And we should also freeze PyTest. What do we have for PyTest? Oh, I don't have, Windows. 902, okay, so it's always better to specify dependencies. Okay, so now we stabilize the environment a bit. Now, so let's see, UV sync, okay, UV lock, we're good. Let's add this thing here. Stabilize depths, okay. And I think I did a bit of changes. Okay, I gotta do rough. Okay. Yeah, these are just string changes, and the project we just reorganized, so we can do git add src stream language template instrument utils stream main. Before we start looking at data, let's remember what data we had, and let's just verify that this whole module still works. So how do we verify that it works? UV run -m stream.main files. Yes, we want to run it with files. Okay. What else do we have? Project name output. Okay. Language Python. That's it. Okay. So now what we should do is, because we wrote the Python solution, we wrote by hand. Okay. We have the project manager software, but we don't actually use it in main, if I remember correctly, right? Yeah, we don't yet. So not everything is hooked up together, which is okay. For Python, we have a static solution because we have a completed Python solution. And we wrote a way to execute code. We wrote a way to write generate to files, to generate use statements. Okay, so now we have the output. So now the main gives us a folder with the files. And the way we test it is we test it first by inspecting. And then we just run okay, everything looks good. Let's just run the test code, UV run -m. Output.test. Okay, so in this case, the problem was solved. Everything is written to disk. Now remember, DSPy is pretty complicated. This is all with iterative execution feedback that we wrote. So we did a lot of work in earlier episodes. So kind of, if we get to the end here, we have a good guess that, hey, this thing actually works. The only catch is, though, the problem is very easy. And we never graduated from. Now, remember, we're also using a small model, Nemotron 3 from NVIDIA, Nemotron 3 Nano, 30 billion parameter model. It's a free model if you have an Open Router account and you get your own key. That being said, we never graduated past this very basic problem. Okay, and the basic problem that we're solving today, and we've been solving all this time. Let me see, am I doing these splits right? So it has this statement: given an integer array nums already sorted in non-decreasing order, consider the number of unique elements to be k. Return number of unique elements. Well, this is really easy, right? Because it's really easy because the array is already sorted in this non-decreasing order. So then if I have a equals, so it's basically sorted in increasing or equal order, right? 1, 2, 67, 67, 888, 1000. How many unique elements are there in A? Now the algorithm to solve this is really trivial, right? We just walk through the elements, and every time, like if I don't see an element equal to the previous one, that's a unique one. I can just increment the counter, right? And that's it. It's like a 5-liner, and AI solves it like this. I can also do length of set of A to get a 1-liner Python solution. That's it. This is the function, right? Length of set of A. In some cases, AI does that. Yeah, here it actually implements exactly the algorithm I talked about, right? So if the array is empty 0, we have one element, the first one, and then from the second element onwards, if the current element is not equal to the previous one, that's a new one. So I find the second here. I find the third element here because it's not equal to the previous one. I do not find the fourth here because it is equal. I find the fourth here. I find the fifth here. Okay. Well, this is all good. Now we want to graduate to more complicated problems. So for that, we need what in data science is called a data set. There's no way we're going to type problems by hand. We're going to have to find them somewhere systematically and import them here. Okay. So I kind of already know I want a data set.py file. Okay. And so we'd like to turn this into a for loop, right? So for input in, we'll see how to do it. Now there's two ways. We can write some boilerplate now, or let's first look at data sets. Now there's gotta be tons of, if we find a data set, we'd also like to be labeled nicely. We would like a data set that has difficulty levels, at least 3 of them, like easy, medium, hard. That sounds something reasonable for these competitive coding types of problems, right? So let me see if I put this thingy here. So that sounds like something reasonable. So let's find that. Let's find a data set like that. Now, where do we look for data sets? Generally on Google, I would say. There's got, first of all, okay, so we know what we want to do now. LeetCode data set. Hugging Face. Okay. Okay. There's a ton of things people, now the thing with Hugging Face is random people upload these. This kind of already has what we want. And the Python solution. I wonder if we can find something that has multi-language solutions. Oh, there's a starter code, but we're not doing the starter code approach. What else do we have here? Completion. Yeah, there is a solution here. Entry point. Oh, I see. This is like the whole LeetCode infrastructure. But we don't need this because we have... Okay, interesting. So we recreated a ton of these. Now input though. Aha. This guy ran it, this person ran it on AI, it seems, because he also gives us a query and response. Now this looks pretty good. There's already a ton of problems here. Oh my God. Okay, so this is what we want, right? There's 27 times 100. There's 2,700 problems here. Like, this is pretty wild. Yep. So I don't see what could possibly stop us then. Oh no, there's 3,000 to, like, it's basically all of LeetCode. What is the, let's see, how popular is this? Decent, recently. Any community issues? Add link to paper. There is no paper probably. Any closed discussions? Not really. All seems pretty clean. Okay, this is one. Let's not jump right into it. Although it looks pretty good, to be honest. Like, yeah, this is what we want. Like, we want a crap ton of problems, and we'll figure out what the format is. We'll extract the minimal amount from here. We don't need all these. See, because they have a way to run. This completion here is the back-end infrastructure. This is exactly what we want to do, but we want to systematize this multi-language and have AI write this. This is actually a good example of why our project is useful, because somebody presumably took the time to write these, what were they called? And no, not entry points, completion. Yeah, there's a ton of tests here too. What is the backend? Where is the solution? Oh, I see. It just has starter code and entry point. So in this case, see, but this is not fully, because they don't show us. You still have to write this to a file and import it from somewhere. But yeah, so that's what we want to do. We want to automate everything, like, because here they tell you how to run this. But it's actually pretty complicated, because this assumes you respect this class solution, which we also know because we did the to-do trick. We know how to do that. Let me turn myself down a bit. So this is not too hard to do, but yeah, ours is better. Now, it should be pretty clear why ours is better, because first we want this to work in any programming language, and we also want it to actually... Now, I'm curious, what does the test code do, for example? Does it call the solution? It should. It calls the function. Yeah, it's pretty complicated here. Okay, so this is good. We all need the problems. Okay, now before we jump into this, although again, it looks pretty good, what else is there? A ton of stuff, because this stuff is popular. Right, so basically some other person extracted, again, LeetCode, thousands of problems. Oh, it's probably the same. Oh, these are all just website dumps, right? How many? Does it have more downloads? Not really. Does it have more discussions? Python solutions mismatched with content doesn't sound good, so we don't want this. Another data set of LeetCodes. Another person did a website dump. Community, no discussions. Probably about the same thing, right? Paid only. We don't need this. But there's no problem statement? Oh, I see. There is no, I'm not sure what's happening. Is there a problem statement here? There is no problem statement here. This is something else. This is metadata. Okay, we don't care about this. We don't care about this. Okay, we're going with this. So, the problem is they have examples. Okay, so we're gonna have to trim this text a bit, actually. I don't like the examples in the text. What we should do is we should extract those and turn them into our cases. Yeah, we're gonna have to widen our system a lot. This is interesting because first of all, our cases are it's a jagged array, and we have this magic function called write jagged array to file, but we're assuming it's a list of the inputs and outputs are lists of integers. This is not gonna fly anymore because we have strings too, so we're gonna have to broaden this list of integer or strings. And funny enough, the project manager wrote better software here. Yeah, because we want to write it like this, array representation. I think this is interesting because AI already did a better job than the project manager we wrote by hand, because here we write final destination stem, but it should be array R. Okay, we're gonna have to mess around with this. So let's see. I'll leave a to do. Extend this for strings and floating point values and matrices. Okay, so these are three different directions of extension, because right now we can only handle lists of integers. And so extend this for, okay, we have a lot of work to do. Pretty interesting. Strings, floating point values, matrices, arbitrary inputs and outputs, number of inputs and outputs. Because right now we also assume the input is a single list of integers or a string. We already messed a bit here. We should not mess with this for now. Okay, so yeah, we're gonna have a lot of work to do. So, but before that, let's import and play around with the data set. Okay, so now the thing is, we found the data set on Hugging Face. How the heck do we use it? Well, usually we're gonna have to download it and use Hugging Face.datasets. Do they have a GitHub of their own? They do have a GitHub of their own. Is there code that shows me how to use this? There's no way we're downloading this repo. This is pretty wild. Why is it on Hugging Face? Oh, come on. Use this data set with data sets. Oh, here it is. Okay. This is kind of the whole point, right? Okay, so then, well, guess what? You would think, oh my God, I need to install dependencies. Let's put the to-do here. Let's see. Ingest dataset. Parse problem statement. Extract test cases. Write them to file. more generically. This is the string stuff we talked about. And I think this is enough for today. And well, measure accuracy. I don't think we're gonna be able to do this because I'm still on the free account, but I mean on Open Router, and have limited throughput, but it's fine. And I can actually crop this a bit then. Okay, this should be good. Okay, so how do we use the data set? Well, it tells us here. So, okay, from data sets and for a load data set. Well, that's it. Okay. And am I gonna need a token? We'll have to see what this annotates, but basically we want this and return DS for now, okay? Well, we want to encode the name if the name is equal to... Well, actually, let's do it even better. Let's assume the user knows what Hugging Face is. And let's... Okay, so the default name will be this, and then we'll just load it. Pretty basic, that's kind of the whole point. Now the thing is we need to UVXROF format. We need to install datasets, but not really. We just need to do UV add datasets. That's it. It's installed and all dependencies are solved thanks to UV. There we go. The only thing I don't like is that it doesn't lock the version. So we look at what it is and say, okay, dataset equal 450. Boom, we're done. Okay. Magic, and let's add this. We're already there, so we can do get status, right? Yeah. What did we change here? Oh, I see. Get add pi project, UV lock, and stream dataset. Basic dataset. We're done. Yeah, let's add the to-dos too, I guess. So just we have a clean history. Add to-dos. Okay, now what the heck is what does load data set return? Because I am not too familiar. Now there is a bug here in VS Code. Pretty sure it doesn't capture the... It won't capture the interpreter, but... Oh, it does, okay. So what is Hugging Face load data set? It returns... Oh, it's a dataset dictionary. I think I remember this. Dataset, okay, so from datasets and it's dataset dict. Okay, so let's see what this entity is, because I forgot what a Hugging Face dataset is. And for that, we can just write a mini main here. What is it? If name is main. The first time we're gonna run this, get dataset, it will, and we want to breakpoint to see what it is. First time we run this, it's also gonna uv run -m stream.dataset. It's also gonna download the dataset, I hope. Yes, okay. 93 megabytes, that's it. Okay, good. So I think it's a pandas data frame, if I remember. What is DS? It has a, okay, I remember now. So it has a train and a test. DS train, okay. And is this a data frame? So for example, if I look at problem description, I'm gonna see a data frame with, okay, I think so, yeah. Length, okay, yeah, so this is just So if can I slice this? I can't slice this by 0 and keys. Okay, there we go. So then it's just dataset train, and the integer index is and it has a length. Yeah, the index is the problem ID, the LeetCode problem ID, and then it has a bunch of keys, which now what we care about for our DSPy module. So if you just joined, we want to use DSPy to sort of automatically prompt this this AI-based competitive coding problem solver. And to do that, we're going to use the library called DSPy, which kind of handles all the prompting for us. I talked about this in the previous episodes of this series, but the point is that with some minimal amount of prompting, DSPy allows you to define the inputs and outputs, and you sort of get the diagram that looks like this. We want to take in the problem description. We're going to take in 3 inputs. One is not shown here. Well, it comes from this file adapter. But then we want to take in a problem description, like some sort of LeetCode style problem, and input-output pairs optionally, either integers, floating points, strings. We're gonna have to make these formats more general. And a file structure, which we want the AI to write and obey all the imports. And we want the AI to output multiple pieces of code, not just the solution code, but also code that measures the memory and runtime performance, and test code for the solution. And then to avoid leaking logic, then we're gonna have to tell the AI to use Python import statements to reuse this solution code, because sometimes it's not that easy. AI can trick us, and we did a bunch of stuff. But anyway, so now we are at the point where, okay, so then I have the data set, so then I can just import this. So from stream.dataset, import get dataset. And let's just get all the data set. How can I filter for the easy ones? What the heck is this? Features. Yes, I can, because I can do difficulty. And I say equals easy, and I get a list. No. 0. Okay, so I do diffs equals I. Okay, so I have to do a list comprehension here. Well, this is actually like is easy. For I in range length ds train. Okay, so now I have an array which tells me which problems are easy, and then can I filter the data set? Easy ds train is, I believe so. Yeah, okay. No. Why so little? No, this looks about right. These are not 14 problems. Oh, it's definitely not 14 problems. And okay, I lost the cons. No. So why just 14? What is sum is easy? Yeah, it should be 638 easy problems. I need to learn a bit more about data frames then, because something is messed up here. Let's see. Oh, I see. So using data sets. So I import, okay, split, sure. Not that this matters. Push to hub. Okay, we need more docs here. Data sets, filtering, processing data. This is what we want. Go to latest documentation. Okay. So reorder from load data set, blah, 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 blah. Or processing return new data set object. Modification is not done in place. Overriding your process the label. Use sort to sort column values. No, we don't want sort. Shuffle. No, we don't want shuffle. Select and filter. Filter. Okay, so still I see. So we have to use these ops. Oh, this is the one we want. Filter returns row that met specified condition. So easy will be dataset.filter where the difficulty is easy. You can also filter by indices. Okay. Split, shard. Okay, well, filter is the only one we want. Let me see the docs here. Yeah, like this. So X label. Okay, so it's just with the lambda function, right? Yep. Okay. So let's load the data set. Now all this is kind of gone. So what instead we want to do is we want to say run inference on each problem. Okay, we have a lot of processing to do though, because what was the code before? We need to spit out the cases array to give the AI examples of this is the input, this should be the output for the problem. We also need the natural language description of the problem is easy, except this data set that we found merges them because it has, let's see, this is the data set. So if I look at the data sample here, the only problem is that the examples are baked in the problem description. So I think we're gonna have to do some parsing. Damn, this doesn't look too great. Is it templated like example? It's always example one, example whatever. And then it's constraints. I think we have to assume this, right? So we're gonna have to do a bit of string parsing here in Python. So, and also we're gonna have to parse, oh my God, okay, we're gonna have to parse each example because our solver doesn't have string names. It will just take the raw array for input and the raw array and or value. I guess in our case it'll be an array with a single value for output. And also we need to deal with two inputs and with matrices, which is basically everything I had in the to do there. Yeah, so we need to extend this because we're gonna have to write these arrays to valid Python code, or I should say we need to write the inputs to valid Python code. Damn. So okay, let's do it this way then. Let's do test-driven development because this is getting kind of hairy, right? So why don't we write the new test file? Because we don't want to kill ourselves with all the cases. So we'll say test write cases to, well, test write cases.py. And basically we're gonna import our function here that's responsible for writing, and we're gonna see what it writes. And we're just gonna throw a bunch of tests at it and we'll fix them one by one. So what do we want to do? From stream dot language dot python, no, dot completed dot Python import write jagged array to file. Now the name of this function is gonna have to change because it's not even, the first time I did this, I kind of anticipated it'll not be a regular array, but it's way more than that. It has to handle strings, floating point matrices, even 3D tensors, a bunch of stuff, and multiple inputs. So let's write some tests now. So test, one input, one output. This is the most basic one, right? Where we say, well, we have no inputs. We'll clean this up. We're gonna have to properly use PyTest, which we can parameterize. But before that, let's write the test one by one. So a basic thing will be what? Now the format for this is also, okay, I see what's happening here. So this is a list of cases. So this external list is always fine because this will be the list of examples, right? So if our data set has example 1, 2, 3, this Python list on the outside will have a length of 3. So this list is fine. Where it starts to not get fine. No, the tuple is also fine. The tuple signifies inputs and outputs. Okay, so maybe it's actually not that far off. So we always want list of tuple here, because every problem has an input and an output. Now the problem is, right now we're assuming that the input for a specific example is just a list of integers, and the output is also a list of integers. One first generalization is to assume that the input is a list of lists of inputs. This accommodates multiple inputs, possibly of different lengths. The output still remains a list of integers. But some inputs could be strings. Okay, so maybe this is not that hard, right? So the input is a list of either list of integers or strings, or list of floats. Same for the output. It's either the output is, let's assume for now the output is just singular, although it's not hard. We just wrap this in a list. So it's either a string of list of floats. Okay, but what the heck do we do with matrices now? Well, shit, I can write it like this. So it's, okay, so this signifies that an input could be either a matrix or a vector. It could also be a plain scalar or a string. Let's rearrange these better, right? So let's start with string. Okay, so it could be a list of instances, and the same thing for floats. A list of, it looks ugly, but I think there is a pattern here that's gonna, okay, now what about 3D tensors? Well, we're just gonna add, it's not the end of the world, right? Like, whoops, I messed something up here. If we want 3D matrices, we're just gonna, now my question is there a way to type annotate these generically? I think so, because this looks pretty horrible. Like, sure, we can keep adding list, and at some point it's, oh shit, no, it could also be a list of strings. Damn. Right. Maybe I should have reordered these differently, sorry. Ah, okay. So it's like this. Okay, this looks a lot better, kind of. Doesn't really do much. But the problem is I forgot that there's nothing stopping LeetCode problems for saying here's the list of strings. Matrix of strings is pretty rare. But my question is there a way to just, can I just do like, is there a type annotation for possibly deeply nested list of strings? This is what we want. And I believe so, there must be, because this seems like a common trope, right? So how do we find this? So let's see. How to type annotate an arbitrary dimensional tensor Python. I think Gemini should oh, but not JAX though. Python basic. Oh, I see. So there's in typing something. So what does it want? Any? Oh, come on. Like, so NumPy has ND array. This is not the worst, but we don't want to use NumPy though. There's no core library thing. Let's ask Gemini. So let's see. So let's do it this way. So I have this type annotated Python function. As you can see, it looks really ugly, and it could also deal with 3D tensors, 4D tensors, etc. Is there a more generic but core Python library way of typing arbitrary ND tensors? That type int is, yes, I know it's a wall of text. Okay, so the scalar is string and float. Okay. Nested array. Oh, it's a recursive thing? Oh my god, this... it's not bad. So it's either a scalar or a list of itself. Not bad. This looks a lot cleaner, right? Collapses the massive union. It handles jagged arrays. Yes, that's what we want. Oh, there's a typing protocol. Sequence. ND array. Deep recursive protocols can sometimes slow down. Anything new in Python 3.14 that makes this cleaner? Because I know there was some lazy typing which may actually help here. Python 3 is a new generic terms, but a fundamental shift. Yes, we know this. Deferred evaluation. Well, this might sound like internal. Directly solves... Oh, come on. Oh, okay. Yeah, so I can just type this then. Nice. Because we have Python 3.14. Okay, this is it then, right? So we just do... I knew it was going to be, let's see. And this may solve a bunch of problems. Right, so we have the types, and then what do we say? So now let's go back. So the array is, the first list is always fine. Let's just write this from scratch because we want this to be a list of examples. Okay, so it's always going to be a list. The tuple is also fine because each example has inputs and outputs. So it's a tuple of two things. The first thing is a nested array of the scalar. And the second thing is a nested array of the scalar. So this handles any possible input. That's either scalar, list of these guys. But wait. Oh shit, hang on. Wait. I also want to cover the case where a mix of lists is allowed. This is... Oh, no, but it's fine. Wait, because the scalar is OR, right? So then this tells it could be anything in each entry. Or does it lock it to one? No, okay. Actually, this is too generic because it could even cover a case like which... So this probably even... Well, actually, you know what? We can... This is why we wrote the test. So now, let's see. Write jagged array to file. Okay, well actually if we started with AI, let's just see. So great. Now can you write me some Py tests nicely parameterized with arrays, don't copy code, that exercise this function with a few 2, 3, because I want to write combos of inputs. I want to see how it looks like. I'm more interested in the parameterization case. Okay, so I just need path test cases. So list tuple. What was the second input to the function? Oh, we have another thingy, right? Oh, it's the file name where we write it. So how does PyTest work with files then? So we're gonna need import PyTest and pathlib import path. Okay. Do I not need to declare a fixture here? I kind of don't like what he's doing here because this is not... Oh, I see. It's mark parameterize. Array label test cases. So I just write my test cases and I need this. Okay, then I can just do it like this, right? So test write cases to file. We have to rename this function. So first of all, it's no longer write jagged array. So it's gonna be write cases to file. We're gonna have to rename this function everywhere now. In the main tool. Okay, write cases to file. Where else? I think this is the only place where we use this, right? UVX rough format. Okay. We can delete this. It's done. These probably have to be moved to the top. All right, okay, it's getting cleaner. So we have write cases. Ah, shit. No, it's not. Oh my God, okay. How the heck do we write? Oh, this is what we want to test because this writing command is not good. Like what I did here is horrible. So the way it works is I take the file name and I take the name of the file without the extension and I name that as a Python variable and I write that in the file. I write that Python code. So then in cases.py, for example, I'm gonna write the Python code cases equals. Here's the trick though, because I just dumped the array. I think this works though. So I'm actually gonna dump the array as it is. We'll have to test it. Okay. So then we write cases to file. So we just need to do some things now. So it's a list of tuples and each tuple is a case. Okay. And each tuple is a list of it's two lists. Well, two possibly high dimensional things, including scalars. So let's start with the basic one. Blah, blah, blah. And 6. So imagine this is sort of like a test case. This is the input, this is the output. I don't know what LeetCode problem it is. Doesn't matter. Whatever. Now let's say the input is A, B, C, D, E, F. And another, and 2.5. Well, okay, hang on, this is getting too much. And the output is sum. Okay. Another one. 1, 2, 3, 1, 2, 4, 1, 2, 5, and the string. And another list of floats of different length. And it outputs 986, 981. Oh shit, no, wait. And what is the other thing I need for each of these? I also need a file name. And how do I encode the file name? Oh, he does a double tuple. Like tuple. So then I put the file name here. Is that what Gemini did? I think so. Well, this seems messed up because he did a, yes, it's a tuple. But I don't understand, why is this a list though? I think he got it wrong here. This should be directly the... Oh, no. I know what he did here. So these are, oh my God, okay. So, there's more meta structure here. This is the list, tuples, and then outside of the list, it's description, and then it's a tuple, and then, okay. So this is like, he did meta testing directly. So all this stuff are just 3 test cases for a single file. This is good actually. So then he takes this list and he makes a tuple which has this list and this file name as the second element, which is going to... Now what I would like to know is some file .py. Do I need extension here? Oh yeah, I do, because it's a full path actually. So how, this is what I want to know. So actually, where does PyTest write files? Oh, I see, test file. Oh, he uses TMP path. Okay, so he doesn't want any extensions then. But I'm gonna have to do py here. Okay, good. So then we can call this just chaos. Okay. And then finally what he does is, so let's see. I see, I'm just gonna take this. Okay, so I see, so these become, and TMP path, is that a thing? That's a special PyTest thing, right? It must be PyTest TMP path. Yeah, it is, it's a TMP path fixture. Interesting. But I kind of want to see where this goes though. Let's do it in our thing. I want to see the files. See, it gets even more complicated. I know what I want to do. We want to execute these Python files because that should be, it should be valid Python. Okay, this is what we want to do. We need to, sure, we can write, we can assert that the write is easy though, but my problem is I need that to be valid Python code because that's what my AI assumes. He's just gonna copy exact those and then he's gonna do things with it and the things with them in the test code. Well, actually he's gonna import that array. Okay, good. So I take all this junk and definitely need to write this. So TMP works, kind of, but okay, so it's this, write cases to file. And this. There's no way we're doing try except here. This is pretty crazy. Yeah, sure. We're just gonna write it. I don't need this. So basic check, sure, I can do this, but I need a more complicated attempt. Well, execute, run the file as a Python module. Now this is not that hard because we did this before. Because we have UV installed, that's kind of the whole point of UV, we can just open a sub process that tries to run this file. Can I override this, I wonder? Or is this a hack if I do it? Test outcomes. Is it gonna work or is I think it's gonna crash? Maybe it won't. So then I also want PQROS. So we need OS. I'm just gonna make this exist OK is true. Because I kind of want to see these. So I would like to see them in a folder called test outcomes, which actually I have no idea where is it going to be. Is it going to be in tests or in this root? We'll find out. Okay, this looks pretty good. So UVX rough format. We'll figure out the sub process. Let me break here a bit. So yeah, this should write 3. Yeah, this is not gonna work now. Oh, wait, no, it will. So what is the file name gonna be? Let's just have it be label. Oh my God, .py. Okay, so now what is my code logic? It looks at the file name and it strips the extension. So what I should see is a variable called chaos. So I'm actually expecting this code, literally, which seems kind of dumb and basic. But this is it. This should be the Python code that I see here. I think this is it, right? I may have to do the representation thing, so it should be maybe R. I doubt it. I think Python... Let's see. I think it's actually pretty easy then. So what do I do? UV run pytest -k. Test write cases. Okay, so I cannot write like this. I don't understand. Am I not following the... Oh, I forgot. It's a list of... Oh my God, there's also an external list. Right. Okay. So each of these things is... So this is a list of things, and each of them is a tuple, and the first in the tuple is the array, the second is the label. Okay, so this should unpack it now. So, whoops, so I can run... the test cases. I guess I need to do path here. So from pathlib import path, and I'm gonna want this to be a path. UVX rough format. Okay. Yeah, this is busted. Okay, so this is not how I write this to file. Oh my God. What is even recursing then? Is it R? Do I need the representation? I think it's R, right? It's the representation of the array. Yeah. Okay, so we need to go into debug mode because what does Python do if I... Is it string of that? How do I get the string representation of a complex Python object like this? Oh God, don't tell me it's... So if I have A equals... Don't tell me it's not possible. Paste. Okay, so I have A. So if I do what? Print A. Oh, is it just print? So if I do x equals print A, is this a string? Type x. Oh no, because how do I intercept the print? That's what can I do? String A. Okay. It's just string then. So it's just string of array. That's because all basic data types have the toString method, or whatever it's called, repr method implemented. So I can kind of get away with this. Now, again. What am I recursing here? This is insane. What is happening here? So test file. Oh, here's my test outcomes. Oh my god, not test, dude. This is so dumb. My bad. I actually want to test the function, not the test function. Duh. Okay. All right, we're done. This was it. So UVX rough format. Okay, there we go. So is it the file written? Okay, it's written. List of tuples of arbitrary things. Now we can also try to execute it. It's gonna be really easy, right? Cert file was written. So now I can revert back to this TMP because I don't need to see all these. And the run will be what? I think I have a run example somewhere. I know it's subprocess.run. And it's UV run test file. String test file. And I think that's it. This is how I run stuff, right? Command, yes, UV run result. Like this. So result equals. Okay, so then what do we want to assert? I mean, I can try this right now. So UV run test outcomes. Well, actually, it'll be exactly like this. Slash chaos.py. Okay. I think it works in Windows either way. It doesn't work. Okay, yeah. So the file must exist. So this is just a base. I mean, I don't think this can fail. But you never know, right? Okay, all right, pretty good, pretty good. So what do we want to assert here? Yeah, assert result return code is 0. Check successful execution. Okay, so now we genericize this. Now, do I need more tests? I don't think so. There's no reason to. I mean, we can, but we're already writing cases, right? Okay, this is all nice and good, but we need to get back to our data set now because... okay, so let's see. What do we change in the lock? Why? Interesting. Get diff UV lock. Ah, okay. UV lock. Pin data sets. Origin, okay. And what else do we have here? A bunch of changes. We don't want this. We don't need this main. This can go. Okay. Now I think this is the wrong type annotation. I'm pretty sure this is data set. Yeah. Oh no, actually this is not. So what is from pandas? Oh, it's CLS. Okay, yeah. Okay. And what is the difference on main? We actually load dataset. Main is a bit, okay. So before that, let's see. Let's add stream language completed. Python and stream. Now our project manager is stale now. Tests, test, write cases, rework cases to more generic. This is all nice and good, but we broke the PM code because the templates are different now. Gotta be careful here. So the template for PM is no longer jagged array to file. It is okay, so let's not lose the guy here because we want this. So the PM now also has to be aware that this could be anything. And it won't be write jagged array to file, it'll be write cases to file. And it'll be like this, right? Yeah. Okay, and now the test will be write cases to file. This is still a list. This is still good. Okay. And okay. PM code, PM template is more generic too. Very important. All right. And we're done. Now let's go back to dataset because this is all nice and fun and games, but we didn't really do much because we need to finally parse the, so let's go back in our main. So let's see. Okay, we're gonna take a quick break, and yeah, we have to actually take a look again at the data set here. And we're gonna have to filter, yeah, we have to do a lot of stuff. We have to parse. There's no other way. We have to parse. Fortunately, LeetCode has standard problem description, but we have to parse it. So we're gonna need some basic parsing up to example. Then we're gonna have to extract all the examples. Oh shit, it's a Boolean too. Okay, we just found one more annotation then. Booleans, I forgot. Yeah, Boolean is also an output, right? Right. Yep. So template for the PM also needs a Boolean. Not UVX rough format. Now the question is, the Boolean does actually, how does the Boolean, we can delete test outcomes. Boolean is an interesting case. So if I have a list of Booleans and a list of integers and the output, oh, sorry, this is a list. These are two inputs and the output is false. How does this get written to disk? Well, regardless, I can just run PyTest now. Aha. Oh, no, wait, this is something else. What the heck? No, do I not have to do this? What's happening here? Like, oh, come on. Oh, is it because the TMP path is... Damn it. I think the TMP path is deleted, right? Seriously, like, oh, PyTest TMP path delete preserve until end of test. Like, is it? But why? Maybe I'm using this wrong. So TMP path sub, write text. For example, suppose your test needs a large with generate procedure, comparing the same image. You can generate it once per session to save time. Does this work on Windows, or maybe that's the problem? Windows? It says it works the same way. So I have to make that? Come on. Maybe this is what I'm doing wrong. Like, make dir exist okay, true, I guess. What? Can I see what the value is? Okay. So what, this path really doesn't exist? Like local temp? If I search for it on disk, see, users, streaming. Where the heck is app data? How do I view hidden files? Oh God. App data, local, temp. I see it. PyTest of streaming. PyTest 4. Okay, dude, it's all here. Oh, I see. Chaos is here too. Okay, so we actually found the file, which is pretty nice. Okay. And the problem is what? Oh. What is the string here? Test file. String test file. And what, UV doesn't work like this? Like, so if I exit now, I know that file is, I lost it, come on. So I know this is the file. And I can't do UV run on this because of Windows reasons, or what's happening here? So I cannot do UV run C. Seems to work. What if I take this whole thing? Okay. Oh, but it's I see, this double thing doesn't work. It does work. Am I using subprocess run wrong? I believe I am then. It must be that, right? Yeah, okay, I'm dumb. The command is just a string then. Okay, there we go. So, okay, that was an easier fix than I thought. So UVX rough format, we don't need the breakpoint. UV run PyTest. Okay, there we go. Let's add all these things. So tests. It's interesting that we found where the paths are. That's good to know. Okay, so now it works with booleans too. This is what we started from, which is good. That's kind of what we wanted. PM commit make test passable and add bool support. We still need to get back to actually working with the example, so we'll do that after a quick break. Okay, we're back. Let's see, what do we have here? Well, okay, so the last thing left to do is to separate out the where was it? In data sets we put it, right? Yeah. So let's write separate get problem description, right? And we're gonna start from gonna start from string and go to string. I don't think there's any other way to do this, but it's kind of easy. So full text string, extract all text from beginning up to first occurrence of examples. And this is pretty much it, right? So we're just gonna need a basic regex for this. Let's see, how do we do this? So, but extract string up to first occurrence of substring. Yeah, so we can do a partition, right? Yeah, that's it. It's just partition, and this is kinda easy, kinda not. So description, we're gonna have to test this too now. I mean, this is so basic, right? Like what? We're just gonna say, I guess we have to say examples. Now the question is, yeah, we have to do test-driven development here too, because I really don't know what's gonna happen here. Or do I? We can check, we can do a one-time check on the data set. Okay, so let's load the data set then. And I don't even need this. Like, well, maybe I do, right? Yeah. Yeah, we'll just new facade, LeetCode. Yeah, let's keep it like this. What is useful is to annotate this here, because it allows us to jump to it without having to switch files. And this is from data sets. Well, let's just do import data sets then. Okay, and it's datasets.dataset. And what else do we need from here? What did we just call this function? Get problem description. Because what I'd like to do now is I'm just gonna walk through these, right? So for sample in DS train. Okay. Description. Get problem description of sample. Oh, I forgot what the key was. It was, we know from Hugging Face. Do we? Yes, problem underscore description, obviously. And we can do some checks if examples in desk raise value error. Examples should not be found in the problem description. Don't think there's a better way to do this then. Yeah, we have to check this at runtime, right? If our parsing is right, it's like dynamic testing. Because I mean, we can write the PyTest, but what? We're not gonna walk through all the data set in PyTest. and we'll never know if we catch outliers or not. What else should happen here? Should not happen. Is it always example 1, I wonder? So up to explanation, all right. No, up to constraints or the end. Yeah, some examples have an explanation, others don't, but they all have input, and in the input they have a list of variables. We have to turn this into a list of variables. This is the input, and the output is usually presented in raw form, so we can take that as the second element of our tuple. Oh man, this is gonna be rough. We're gonna have to validate all the outputs. I don't think it's that bad though. So we just split on examples. Then for each example, we split on input and output. Yeah, from input to output. It's a ton of splits basically. It's not that bad. Then from the inputs, for the inputs, find all the equal. Like, what the heck is this? Find all the equal symbols. And okay, so delete stuff to the left up to the first comma. I think that's the rule, right? Because here I can go back. Yeah, I can't go to the right, because to the right I have comma here and I'm gonna go insane, right? If we see a matrix. But if I go to the left, I can't delete things. And that's it. Then put brackets around the thing, and that's it. That's the input. Yeah, I think this works. Not the easiest, but it works. Alright, so for each equal, delete stuff to the left. And one character to the right if it's a space. Okay, sure. Delete stuff to the left up to without the comma. This is without the comma. Put brackets around the thing. Done. Output is easy. Cut the explanation up to example. Delete stuff to the left. Oh shit, there's a null value too. Okay, null is null in Python, or am I tripping? I think I'm not tripping. Is null valid Python? No, it's not. Oh god, we have to do this too. So this has to go here. Uh-oh. To do accommodate null scalars. They should be none. Interesting. This is something for the PM to do, actually. It's, there's a mini parsing problem there. Oh boy, but the inputs are nasty though. Wow. So we're gonna have to deal, the PM will have to deal with this too. Okay, sure. Of example. Okay. Can I put a wildcard here? With wildcard. Everything before the first match. Dot matches any character except new line. Oh no, that's not good. Error decimal 2. This is what we want, right? Okay, we have to do it with RE. It's not that easy, I think. So, okay. And what do I have in parts? Okay, desk is part 0.strip, full text. And this is D1. And it's example space. Okay. Okay, so now we're cooking. It's a lot more robust. And if I do split care, if capturing parentheses are used in the pattern. Let me see what this is then. This is a good learning thing because I don't know what these parts are gonna look like. Okay, so let's see. UV run -m stream.main. Okay, we're good. So we're deep in here and we have a full text, which is probably the first problem description. Yeah, okay. And it has example. Actually, we can do even better. Well, too late now. We have a delimiter pattern. Parts. What the heck is, how many parts are there? 2. Oh, because I put max split 1. Oh, shit. Well, how much max split do I have to put? What if I leave it infinite? And let's also put semicolon to be even more robust, sure. Okay, parts. No, length of parts. 4. Now this sounds better. Part 0. Okay. Whoops. Ugh. So print part 0. Okay, so we already have the description. We're done. But Okay, so then we can move on to the next function, get cases, which is gonna be the same thing. We'll do it separate function, I think. No. Maybe not. Yeah, we should do it here because then I don't want to change the pattern, right? Okay, next up, print parts 1. Oh, I see. It's actually the without the delimiter. Wow. Parts 2. The only problem is the last part will also have constraints. Can I do an or here then? So split at example or and constraints it should be. Okay, okay. I like this. Because so then what I have to do is so re dot split on 2 different patterns. Does this work? Combine the patterns using the alternation operator. Or define the character set using square brackets. I'm just gonna do alternation then. This sounds the more basic, right? So or constraints. I don't know how to mark a character as optional. Let's see, what does this do? Length of parts. Oh, not good. Print parts 0. Nah. Why not? So I don't know how to use these then. And where the heck is the... Oh, this looks exactly... Oh, I see. It's because... Oh my god, wait. Oh, the spacing matters. Sorry, I know what happened. Because there is no... Oh shit, the spacing is strict here, right? Yeah, that's what happened. Again. Aha, okay, so the spacing is very strict there. Interesting. Now parts should be 5. Yes, okay. Okay, so these are the constraints. Okay, good. So then by definition we know... Okay, perfect. So description is parts, okay. Get all examples. Okay, so extract inputs, input output from all examples, because now we know the examples come after the description. So for I in range 1, length of parts -1, I need to have at least 2 parts. Yes, there's no way. No, 3 parts I need to have. Right, so this assumes... So we can do it like this. If constraints not in... No, I'll do it this other way then. So if constraints not in, because we want to flag outliers, we have to do test-driven development here. There's no other way, I think. Yeah, there is no other, because this is a data set some person wrote, or I guess the LeetCode GitHub admins decided. So there's found a sample without constraints. So this is going to be important. We'll have to know. If we find something like this, we'll accommodate it. For now, let's assume it's there. So then this is at least 3. So we have at least one example, okay? So we have example will be parts of I dot strip. And we're going to have, what is this? Cases, right? And we're just going to return cases. And now we're going to do the tricky here where we say from stream dot language dot completed dot python import, what do we call those things? Scalar and nested array. Okay, so then the output will be a tuple of string and the ugly a list of tuple of nested arrays, which is the somewhat, that's not too ugly, right? Yeah, I guess we could write the fancier thing. So type cases, right, will be list of tuple. Okay, there we go. Might as well leverage Python 3.14 and yup, list of tuple of nested arrays of scalar. Gotcha. Oh, okay, then we definitely need this because I don't want to copy this in 5 places. Yeah. So then we're gonna say this is just cases. Also, the PM needs to know this. Yikes. And the PM needs to know it's cases too. And let's see what Ruff says here. Does he want to refactor? Nah. I guess it's okay. We can save a line here if we do this, right? Ruff will change it now. Yes, he will. Okay, so let's save a line then. Very good. Okay. Back to the data set. So we have cases now. So it's just a tuple of a string and cases. Good. So description is a string, cases is cases. Okay, so cases, right? So then what we want to do is we're gonna do input equals, so case inputs equals something, case output equals something, cases dot append the tuple by case inputs and case output. Okay, and we're gonna return the cases. And that's it. And then we're gonna say the problem description is description cases. Aha, so now finally very good. So we have the cases. Right, cases. Well, we don't need this. But we're gonna have to do this inside here. And we're gonna say form inputs. So yeah, now we're predicting on... Oh, there is a trickery here though. Okay, let's do it scalar for now. There we go. So now we moved everything. So project none, problem. Aha, this will be description. Very good. Cases will be the cases we just wrote. That's it. So now we just need, let's see what the UVX rough format wants to do. Okay, not too much. Let's put this all down. So then we just need to do some more parsing, which we can finish next time. But yeah, this is pretty much it. Parsing these is not gonna be hard because we discovered the regular expression stuff. It's actually gonna be another delimiter pattern, right? So we'll do, so in each of these, what do we want? So how do we find, okay, so we need an RE way to extract text between 2 blocks. So that's the only thing we're missing, right? So Python RE extract substring between 2 strings. Between 2 specific strings, you can use capturing groups with non-greedy qualifier. The search will find the first match, find all. We're gonna do a find all. We can assert there's only one, there should be. But can I not parameterize this? I mean, this is pretty basic, but the pattern is... Okay, I'm just gonna look at what these guys did. Because I want something generic though. Python 2.x. Part 3. So what do we want? Dot. Oh, slash dot because it's an escaped thing. Yeah, this is pretty basic. Okay, so we have to do it like this. We just have to... I don't understand why... Yeah. Well, sure, okay, we'll do it this way then. So what does he want? Start string. Okay, so the start string will be input and the end string will be output. So extract inputs. Can I use this here? Like start? Is this how this works? No. Example. If length substrings greater than 1, raise runtime error. Input extraction failed. Found more than... Nah, yeah, this is not gonna happen. The problem we have though is... So case inputs is substrings of 0.strip. Well, something like that. We still have to process. Delete all named assignments by looking to the... Okay, so we're gonna have to... Oh, okay. The easiest thing is if I just turn this into... I think I'm gonna do this myself. Like, can I just turn this into a list and... Yeah, we should just do this ourselves. The funny thing is this is a LeetCode problem. But hang on, we have bigger problems though, because how the heck do I use... So use Python string variables in regex pattern. This is the problem we have. Oh, it works like RF? Oh, interesting. I didn't know that. Wild. Okay, let's see what this yields then. And repeat the same for output, right? Because for output is the same. It's kind of the same. Did we stop midway or something? We did stop midway. src stream main git add. What did we change here? Oh, okay. Test write cases, and this should be it. Parse description out of statement. Okay. Let's see. We forgot the breakpoint in here, but it's fine. So uv run -m stream.main. Main. Okay, we stopped exactly where, did we? Yes, 31. Substrings, is it just one? No, it's not one. Oh, okay, so the pattern worked. What? What is the example? Oh, this also worked. And why the heck do I not see? What? Input, output. And then the other one is explanation output. But why do I not see? Find all pattern string. So do I just like do star? Like this? Is it even more basic? Find everything between that? Substrings. Why? Do I need to escape the semicolon? I think so. I think there's some trickery here because this has to be an escaped semicolon. And this is probably fine, like everything, right? So what is pattern now? Oh. No. Okay, we have to ask Gemini. What is wrong with the following regex? It doesn't find anything in a valid example. Dude, I swear. Oh, I see re.all. So yes, I want the greedy and I want re.all. Okay. I see. So what was the thing here? Was it the dot all? Yeah. Okay. So then we have case inputs, strip, case inputs. Okay, so now we go delete all named assignments. Whew, okay, so we're gonna need a subroutine then because this is getting kind of hairy, right? So, let's see. Nah, we don't need it because the nah, the outputs are easier. Actually, we don't need a subroutine, sorry, because the outputs are easier. Actually, let's do the outputs then. Case outputs. Because the outputs are easier. The outputs will be like this. Start string is output. And string is, what was it? Example. Explanation. Okay. And the pattern is exactly the same. Pattern substring, and that's it. So actually the case outputs are the first. So output extraction failed. But the only tricky here is that, wait a second, how do we evaluate this now to Python? Aha, this is where the null thing happens actually. So it's not here. Oh, is it? Yeah, I think it is here. Okay, so we just need a none here. Now, okay, this sounds easy, but it's not quite that easy because we're gonna have to convert here. We're gonna have to convert. Okay. To do convert null to Python none somehow, which I don't know how to do. In fact, my more generic problem is I need to evaluate. So here's the trick here. We're gonna have to evaluate this string here. So if length is not 1, let's make this even stricter, right? So we want the length to be exactly 1. Yeah, because that's how our parsing works. Okay. The problem is, okay, the outputs are the easier ones. Okay, there they are, case outputs. My question now is, do I need to do eval case outputs? Yes, I do need to do eval case outputs. So it's actually eval of this. Oh my god, okay, there's a trickery here because if I eval... yeah, so I need to catch... eval is a sub-process run, right? So... I need to catch eval error then. Try... except... E. We need to, how to catch Python eval error. Simple, trusted. Okay, so definitely want to do AST literal eval. For security, because we definitely care about security. Now that's not the problem though. How the heck do I... okay, this is all nice and good, but... except what? Oh, do I... how is there... I guess I'll take these two guys. I don't know what all the possible is there a finally? I think there is one. Okay, so try except finally, right? Let me remind myself. Try except finally Python. What is finally? Can I use? If no exception code that always runs. Oh, so sorry. So I need to raise this myself, right? Yeah. As E. Output evaluation failed. So can I raise a runtime error? And can I print the E myself? Do syntax errors, do they have repper or whatever? Base exception. Yeah, it has a repper. Okay, so I can print this. Okay, so yeah, I'm not quite sure what the heck am I doing here. I mean, I'm raising my, yeah, it's just error, like summarization. We don't need a finally block. This is very important, right? Yeah, so we're gonna have to extract and we're gonna have to, we're very close. Now we just need to delete all named assignments from inputs. So we're gonna go like this. List case inputs for char letter in so I'm gonna do what, the double for loop where I find all the I think so, right? I find all the equal symbols and I cut to the left until I hit the comma. Yeah, it's kind of dumb, but I think it's safe enough. I think this is fine. Yeah. No, it should be okay. Oh, wait, this is not valid Python. Never mind. So if letter is equal, so let's to pop. Let's do it this way, right? We'll just mark the stuff to pop. And we're just gonna go from an I. And once I is okay, and then I'm gonna go for J in range. So first we're gonna to pop dot append I. And we're going from I minus 1 to minus 1, so down to 0, okay? And we're gonna say if J is comma, no. If case inputs of J is comma break, otherwise we're gonna do to pop append the J. And that's it, because I do the equal to the left, that's it. And for I in to pop dot reverse case inputs dot pop I. Case inputs is back in the string case inputs. All right, let's see if this is a pretty basic algorithm. Yeah, this works with dynamic programming too, because actually we want to keep track of the last comma too before the equal, and then we can just pop. Yeah, so every time you meet the comma, you start the counter, and when you meet an equal, you close the counter. Okay, anyways, yeah, this works in all of one too, but this is so what is this? So reverse. Oh, I see reversed. This works like this, right? I can reverse the list. Yeah. Okay. And I forgot to strip this. Why? Also, I need to strip because we want white spaces. So what do I have to pop now? Let's see. Okay, so I guess string of case inputs. Oh no. Sorry, it's dot join case inputs. Okay. So the first one is fine because what is to pop? Oh yeah, sorry. So sorted. What is sorted? Yeah. I think this is actually the algorithm. Okay. I forgot it won't come sorted. Yeah. Okay, the funny thing, really funny, because this is actually a LeetCode algorithm, but okay. Where did I stop? Why? Oh, I didn't save. Oh, sorry. Pretty good. Okay, and we also need this. So check this out, because we need the bracket, this thing, and closing bracket. And then we need the same thing, because we're gonna have to eval this. Input evaluation failed. Oh boy, I think this is it then. Is it really? Yep, I think so. Nice. Minus the none part. Which is not that hard actually. Why output extraction failed? Am I not getting what's happening here? Is the thing not deterministic? Did I mess up the example in place? Substrings. Well, this works now. Damn it. This is not deterministic though, that's the problem, is it? Do I have shuffle equals true on the data set? Oh, wait a second. So what is length parts here? Whoa. Ah, okay. I know what's happening. It's the second example. Why? Aha. What is this example? output. Oh, it's not. The explanation is just for the... Oh, I'm so dumb. It's only after output, right? Otherwise, it's from output till the end. Okay, so we go like this. So last example is flanked by explanation. So we go like this. If actually, wait a second. Wait. What was the first example that worked? No, because I thought we dealt with this already. The first one that works has substrings 1. Okay, gotcha. What is it? Input, output. Oh, yeah, because it's an explanation for the okay, yeah. Some examples don't have explanations. May not have explanations. So we go like this. If and string not in example, then what? Else this thing happens. Okay, so we need to find this. So we'll say substrings is something. Well, it's easy because it's the split in reverse, right? Yeah. So it's RE split. Parts, where is it? Where am I? Oh, here it is. RE split. And we want to split from the... Okay, we want to split the example by the thing. And I believe it will be from 1 onwards. And what should happen is that the length of that thing should be 1. Yeah, this is nice. Let's see. Okay. Substrings. Yes. Yep. So we want this from 1 onwards. And then if output appears multiple times, that's also a bug, which is going to hit the same error. And that's it. Do not forget to do the strip. No, we do the strip. Okay. Strip 0, 1. So if I take 1 onwards, this is fine, right? Yeah. 0 dot strip. Yep. Okay. Okay. All right. More stuff. Can we finally UVX rough format? Not too bad. Can we get to the description and cases? I believe we can. Yes, we can. So the problem description is this. Very nice. And very important, the cases is a Python object. There it is. A list of tuples. Yep. Yep, for each case is a tuple. In this case, it's 2 inputs. The first input is an array. Yep, there we go. Perfect. We're done. All right. So it's not the cleanest. Whoops. Okay. It is not the cleanest. It's also not the dirtiest because again, oh yeah, convert null to Python none. Very easy. Example dot replace null with none. That's it, I guess, because this is evaluatable now in Python if it appears in a list. The only trickery here is that I guess we can do this to be more robust. If the but the string null, it should only be like this. Yep. Okay, and then we can finally go back to main and we get description cases. And we can run again. Okay, so we have cases, description, very good. We can do next, next, next. Nice. What I wanted to see is that output. Here it is. So it's actually written to Python. And don't forget that this, well, okay. We don't have evaluation, we don't have execution feedback, but if I go and do uv run -m output.cases, okay, this is valid Python code. We are good, that's it. We ingested data now, okay? So now we can predict. Let's just do it for fun. Let's just watch this problem. Now we should see the whole output code for this problem now, which is gonna be pretty amazing. That's it. We actually solved, whoops, sorry. I'm not gonna let the for loop go because it'll keep solving problems, but there we go. Let's see AI working, it's solving this problem, which is the 2-sum. That's the first LeetCode problem. Okay, so we wrote output solution. There it is, 2-sum. There it is. It's actually all our infrastructure works, which is pretty amazing. Everything we did so far is now reused because I can just go uv run -m output.test, and I'm actually testing the cases which are read from the file, and yeah, that's it. It takes 2 inputs, 1 output, and it passes everything. And it measures the runtime of the cases imported on the cases on the solution. All the import statements, pretty wild, very nice. So the dataset integration worked perfectly. Okay, so what do we want to do with the prediction? There's a problem now because the project structure always writes to the same project name, which is output. So we're gonna keep overwriting problems, but this is fine, right? To do, create this per sample. Maybe there's a way to, we'll do this next time, but this is pretty easy so far. That's it. And we're gonna have to also to do log per sample. We're also going to move the logging in the output next time, but this is it. This is DSPy. Like, the main still stays less than basically 100 lines, which is pretty wild. It's 100 lines and like 30 of them are all this file junk that we did. But otherwise, everything works, including the whole Python execution, writing to file. There's iterative execution, feedback, basically this whole scheme, right? So we're done now. So we ingest the data set, we write these 2 files. It was not easy, but we did it. We give them to our solver, it outputs files with the correct imports. The project manager is aware, the files are written, the prompts generate the correct imports, the whole thing works. Okay, so next time we'll see. So we did everything except measuring accuracy. So next time, I'm not sure if we'll be able to do this. We'll have to get a key of sorts, but yeah, this was really nice. So thanks for tuning in or stopping by or watching the video, and we'll see you next time.